You know, for years, we've seen AI absolutely master games, right? From chess to Go, they've become unbeatable. But what happens when you take all that incredible brain power and turn it away from games and aim it squarely at the unsolved problems of science? Well, that's exactly what Google DeepMind's latest model, Deep Think, is doing. And believe me, it's already changing how scientific discovery happens. So let's just start with a huge question. Think about this for a second. Imagine an AI that doesn't just regurgitate what we already know, but actually helps discover things no human has ever figured out before. What if it could literally team up with scientists to crack problems in math, physics, and computer science that have been on the shelf, unsolved, for decades? That's the incredible promise we're going to dive into today. We are really entering what you could call a new frontier of science. And this isn't about an AI replacing scientists, not at all. It's about creating a whole new kind of scientific mind, one that actually partners with human experts to push the absolute boundaries of what we know. And this is what really makes Deep Think so different. It's built for the messy, complex, open-ended problems that define actual scientific research. It's not just looking up answers in a textbook, it's navigating the total unknown across multiple fields. It's kind of like a polymath for the digital age. To get how we arrived at this moment, it really helps to look at the AI's journey. It started out as a kind of child prodigy, acing the world's toughest academic competitions. But now, it's evolved into a full-blown research partner. And the progress has been just unbelievably fast. I mean, look at this. In July 2025, Deep Think hits a gold medal standard at the ridiculously hard International Mathematics Olympiad. Then, bam, just 2 months later, it does the same thing in collegiate programming. And by February 2026, we're talking less than a year later, it was already being used to solve real professional research problems. The pace is just staggering. And you can really see that acceleration right here in its performance. I mean, the jump from the July 2025 version to the one from January 2026 is huge. But look at that third bar. That's a specialized version they call the Aletheia agent. Here's the wild part. It gets even better reasoning quality while using less computer power. This shows it's not just about brute force. The system is genuinely getting smarter and way more efficient. So let's zoom in on pure mathematics, because this presents a really unique kind of challenge. You see, unlike a competition problem that has a neat, clean answer, research-level math means you have to navigate this giant, complex web of existing knowledge, which is something large language models are usually pretty bad at. And this is exactly where the Aletheia agent comes in. You can think of it as a specialist tool, built right on top of the main Deep Think model. Its whole purpose in life is to copy the process of mathematical discovery, generate ideas, check them like crazy for any flaws, and then refine them again and again and again. Now, this cycle right here is the secret sauce. It generates a proof, then it verifies it. If it finds a mistake, it revises and tries again. But look at step 4. This is the real game changer for collaboration. The ability to just stop and admit it's stuck is a massive breakthrough. It prevents the system from going down endless rabbit holes, and that saves its human partners an invaluable amount of time. And the results? Well, they speak for themselves. This isn't theoretical stuff. This is happening right now. Aletheia has authored a research paper all by itself, co-authored another one with a human, and maybe most impressive of all, it solved 4 open problems from the legendary conjectures database. We're talking about some of the most famously difficult puzzles in all of mathematics. I also really appreciate how responsible the researchers are being here. They've actually proposed a system to classify the AI's contributions. As you can see, it's solidly achieved AI contribution and publishable quality, and some of its work is already submitted to top journals. But notice they're not yet claiming any major advances or landmark breakthroughs. It shows a really careful, grounded approach to using this incredibly powerful new tool. But hey, the story doesn't stop with math, not even close. That same core reasoning ability is now being applied across totally different scientific fields, turning Deep Think into a true digital polymath. A really key technique for this cross-disciplinary work is something they call balanced prompting. It's so simple, but so smart. Instead of asking the AI to prove something is true, which can create a kind of confirmation bias, researchers ask it to prove or refute it. That simple change in wording forces the AI to hunt for counterexamples, making the whole exploration way more rigorous and objective. And that one little technique led to a jaw-dropping result in computer science. For almost 10 years, there was this conjecture that just seemed obviously true, but no one could prove it. Deep Think took a look and found a super specific 3-item counterexample that proved our intuition had been wrong the whole time. Then there's its incredible ability to make connections that humans might just miss. For example, it took on these classic computer science puzzles about networks where progress had totally stalled. Deep Think broke the deadlock by applying advanced tools from a completely unrelated field of math. That kind of cross-disciplinary leap is something that's really, really hard for human specialists to do. And over in the world of physics, it tackled the insanely complex math of cosmic strings. Deep Think found this beautiful, elegant solution using a specific mathematical tool that basically took a messy, infinite problem and collapsed it down into a simple, finite one. All of a sudden, it was solvable. And believe it or not, its reach even extends into economic theory. There was a key principle for how auctions work that only applied to certain numbers, not the real-world continuous numbers we actually use. Well, Deep Think applied some advanced topology to extend the theorem, making it relevant for the modern AI age. So, what does this all add up to? When you put it all together, what we're looking at is the dawn of a new era of discovery, one that's going to be defined by this powerful new partnership between human and artificial intelligence. This quote from the research paper just sums it up perfectly. The AI acts as a force multiplier. It handles the painstaking, boring work of digging up knowledge and rigorously checking every little detail. And that frees up human scientists to do what they do best, focus on the big ideas, the conceptual leaps, and the creative direction of the research. So the huge takeaway here is this new scientific workflow. The AI is the tireless assistant, the verifier, the one that can bridge the gap between totally different fields. The human is still the guide, the strategist, the one with the intuition. This isn't about replacement, it's about augmentation. And that is a fundamental shift in the scientific method itself. Which, of course, brings us right back to those big, exciting questions we started with. When you have a collaborator this powerful, one that can see connections we miss and perform logical steps at lightning speed, what becomes possible? Which of the great, stubborn, unsolved problems of science and mathematics will be the next one to fall?